Okay, welcome back, kiddos. Now we're moving on to section 2 of Unit 6. We're going to talk about points of concurrency. Okay, so these are the type of problems that we're going to be working on today. So let's get right into it. What does concurrency mean? All right, so what are concurrent lines? So let's get our two highlighter colors that we want to use today. First one let's use for our vocabulary words. So concurrent lines. Okay, so when three or more lines, rays, or segments, so three or more things intersect at the same point, they're called concurrent lines. So if you see these three lines right over here, they intersect right over there, right? So right where they meet, that's called the point of concurrency. So that point of concurrency is right over there. Okay, so that is the point of intersection between those. So on this example, what would we say the point of concurrency is? We would say that point of concurrency is point P. Okay, then concurrent lines. Which ones are the concurrent lines? Now, one thing is there's a little error here. I got C and A over here, so let's mark out that C. Let's put C right over here. So the three concurrent lines are this one right over here, which we would say is line A. Okay, then this one right here, which we would say is line B. Okay, and then the last one we would say is this one right here that we relabeled, so line C. Okay, so just so we know what these two vocabulary words mean, the concurrent lines are these three lines that do meet at a certain point. With that point where they meet is called the point of concurrency. Okay, so now that we know that, let's get into different forms. So we're going to make different lines on the same triangle, and we're going to talk about how those are different. Okay, so the first point of concurrency that we're going to talk about is called the circumcenter. And so this is our key word over here, circumcenter. So I'm going to highlight that with that same color. Okay, so circumcenters are formed by three perpendicular bisectors. Okay, so this is what we practiced from last time. Okay, so we remember a perpendicular bisector. What that means is that it's a segment that is perpendicular at the midpoint. Okay, perpendicular at the midpoint. And so also we know perpendicular means that means meets at a 90-degree angle, right? So that's what perpendicular means. Okay, so if that's the case, then let's draw those in. So three perpendicular bisectors. All right. So we said a bisector. We know. Let's talk about this side right here. Bisector means it makes it into two equal units, right? So let's think about it. Right over there, if that's the middle, we would show that it's the middle. It may look like the middle, but we don't know until we have those hash marks, right? So let's put a one hash mark there and one there, right? That shows that's in the middle, right, at the midpoint, and then perpendicular. So perpendicular means it makes a 90-degree angle. Okay, so that's the first one. But we said it has three of them, right? So on this line, that was the middle, and then we did a perpendicular. So let's talk about this line right over here. So let's talk about right in the middle. Where would that be? It'll be like right about there, right? Then we said, and you can turn your paper if it's helpful, but we can turn that, and then we're going to go perpendicular. So it's going to go like right there. It's not. I'm not trying to go to this corner. I'm trying to make it a 90-degree angle. Okay, so I would do that. Right, so where these two cross is right here. So if we do it correctly, that third one is also going to cross right there. And that's going to be that circumcenter. So let's do this last side right here. So right in the middle, I would say probably is right about there, right? Okay, so then if we do a line perpendicular, it's going to be like just like that. So just like we thought, it does go right through there. Okay, so that circumcenter is that point right over there. It's where three perpendicular bisectors meet. Okay, so the thing about that circumcenter is it's equidistant. Okay, equidistant means same distance, right? So it's the same distance from each of the sides. Okay, so actually, this length right here is going to be the same as that and same as that. So if we drew it correctly, absolutely correctly, then that would be congruent. Okay, so the circumcenter on this one would be called, if we put a P there, we call that point P. Okay, so the circumcenter is where they meet. Okay, all right, so that's our first one. The circumcenter is formed by three perpendicular bisectors. All right, next one we're going to talk about is the incenter. Okay, so an incenter is formed by three angle bisectors. So this one we talked about last time as well. Okay, so remember an angle bisector, what that means is it bisects the angle, right? Which we remember bisects means makes two equal angles, right? So remember the angle is that corner right over there, right? So if we're going to bisect it to make two equal ones, we're going to think like right in the middle of it, right? Right in the middle. So that's about right in the middle. It's not as perfect. So I'm going to mark it with one arc for that one and then one arc for that one. So even if they don't look perfectly equal, this shows that, hey, they're supposed to be equal. So it's supposed to be an angle bisector. Okay. So then next, what about this one? So if this is like this, then we could say like half of it's like right there, right? Half would be right there, right? And now this one, I'm going to put two arcs there because it's a different angle from this. Okay, so this one right here is two arcs, so then this one should also be two arcs to show that it's the same as that other one, right? Okay, so then lastly, so if we draw this correctly, it should go through there. So this, we're going to cut this one in half, right? So half of it looks like it would be right through there, right? Looks like we did draw that one correctly. Okay, so it goes right through there and meets right over there. Now, this angle, since this one has 2 and that one has 1, let's put 3 on this one, right? So 3. So that side is also equal in length to that side, right? So let's put 3 on that one. Okay, so now, if we looked at this, if somebody looked at this, we would say, oh, this one goes right in the middle of an angle and makes them in two distinct parts, so that's called an angle bisector. So the incenter is created by angle bisectors. Okay, and then the critical thing on this is this one's equidistant from each vertex of the angle. Remember, the vertex are the corners. Okay, so that's the incenter. It's created by those angle bisectors. Next, let's keep it moving. Third one. Okay, this one, ooh, this is missing right over here. This one should be called the centroid. Centroid, okay, and then this one's a very critical one. This is the most important one that's probably going to be tested. So we want to make sure that we really get this one and recognize that this is the crucial thing that we need to recognize. So the centroid is formed by 3 medians. Okay, that also is one we talked about last time. So we remember the medians go from the midpoint to the opposite vertex. Okay, medians go from the midpoint to the opposite vertex. So if we set a midpoint, midpoint's the middle of the line. So let's think about this side. So the middle would be like right about there, right? So let's put a dot there. And we're going to show it's a midpoint by putting equal hash marks, right? So if I said this one had 2, that has 2, that means that's the middle, right? So midpoint to the vertex. So on this one, this first one, that goes from the midpoint perpendicular. The difference is this one's going to go from the midpoint to that vertex. So we're going to go like that. Okay, so now let's do this side. So where's the middle? Middle on this one's going to be like right about there. Okay, so let's put 1 on that one and then 1 on that one. So that shows this side is equal to that, but it's different from this side and this side, right? So we said from that midpoint to that vertex. Okay, so if we do this correctly on this last one should pass through there too. So let's do this last side. So this last side, the middle is going to be right there, right? So let's go to that vertex, and boom, we did it basically correct. All right, so that's the, right over there, that's going to be called the centroid. And we said it's created by medians. Okay, so medians, when we see that keyword medians, we're going to think centroid. When we think angle bisector, we're going to think incenter. Okay, when we see circumcenter, we're going to we're going to think perpendicular bisectors. Okay, then our last one. Last one's called the orthocenter. So the orthocenter is going to use another one that we haven't talked about yet. So we talked about, in the previous days, we talked about medians, angle bisectors, and angle perpendicular bisectors, right? So now this last one we're going to talk about, is called a altitude. So what an altitude is perpendicular, right? Perpendicular, we know, makes a 90-degree angle. Perpendicular from the base to the opposite vertex. Okay, so it goes perpendicular from the base to the opposite vertex. So let's think about it. If we're looking at it like this would be the base, right? So perpendicular to the opposite vertex. So that means it needs to go straight up and down. So we start at that vertex and we go straight down. Okay, and then if we do that, that makes a 90-degree angle. So that's called that altitude. Okay, so the altitude is this line right over here. Okay, so keeping that in mind, let's go ahead and go with our last one. So the last one we're talking about is called the orthocenter. Orthocenter is formed by 3 altitudes. Okay, so we said those altitudes are perpendicular from base to the vertex, right? So on this one, let's think about this. So we're going to start from that vertex. We're going to go straight down, okay, and we're going to make it perpendicular. Then on this one, we're going to start from that vertex and we're going to go straight down, right? So if we're thinking about this base, okay, so from that base to that vertex, right, and making a 90-degree angle. Okay, then the last one, so this base going to this vertex. So we're going to start from there. Imagine if this was on the bottom, right? So we do go straight down, and it looks like we do that perfectly, right? And we're pretty close to perfect, right? And they meet right there. So that's called the orthocenter, right? This is called the centroid, okay? And then this one was called the incenter. Okay, and then that last one's called the circumcenter. So those are 4 ones that we learned. So the altitude, those are create the orthocenter. So the orthocenter is created by altitudes. That's what we want to remember. Okay, so those are the key words that we're talking about. Altitudes go with orthocenter, medians go with centroid, angle bisectors go with incenter, and perpendicular bisectors go with circumcenter. Okay, so keeping that in mind, see if you can pause the video for just a moment and tell me which one of these is which one of these. All right, let's look at this first one. Let's look at the key information that we should see on this one. Okay, so let's look at this hint. This first hint, I see this and this. That tells me this has to be the midpoint, right? If this is this or equal, that means that has to be the midpoint, right? So then it goes from the midpoint on one end, so we're going to look at both ends, right? So look at both ends. And the hints. Okay? Both ends and the hints. So that end, and then it goes to the vertex. So we need to see which one goes from the midpoint to the vertex. Which one goes from the midpoint to the vertex? Okay, we write right here, midpoint to the vertex is called the centroid. So we're going to call this one the centroid. Okay, and that's created by medians. Okay, so those are the key words that we need to think of. Medians create a centroid. All right, let's look at this one right over here. Okay, so what do we notice about this one? Okay, so this one has this right here, right? What does that tell us? That tells us it's perpendicular, right? And then what's on the other end? So one end is perpendicular, on the other end is here. So perpendicular to the vertex. Okay, so let's look back at our notes. Perpendicular to the vertex. Ooh, actually, this looks right over here, right? This last one right over here. We said the altitudes are perpendicular to the vertex. So if those are altitudes, we know altitudes create a orthocenter. Okay, next, let's look at this one. What do we notice about this? Okay, well, let's look at those hints, right? That tells us that right there is the middle, right? So if that's the median, if that's the, I'm sorry, not median, if that's the midpoint, right? If that's the midpoint, and then this tells us that it's perpendicular, okay? Well, if that's the midpoint, then that tells us it's a bisector, right? So if we know it's a bisector and it's perpendicular, that means it's a perpendicular. It's created by perpendicular bisectors, right? So perpendicular bisectors create a, what do we say from our notes? Perpendicular bisectors create a circumcenter. A circumcenter. Okay, then our last one. What do we note about this one? Last one, we see this. And now this is the only one that has this. If you look at one end, we have the vertex, right? The other end just goes to the other side, right? So the only one that has that are angle bisectors, right? So the only one that has that picture of the angles is this one right here. That's called the incenter, right? So the incenter is created by those angle bisectors. Okay, so these are angle bisectors. And that's the incenter. Okay, so that's the information that we need to do our final practice. So let's get right into it. All right, so let's look at this one right over here. It says point, we're going to say what created, what we're using, and what does it create. Okay, so it says point D is the what. Okay, well, let's look at this. We have these right over here, and this is perpendicular, right? So perpendicular, and it's at the midpoint, so it's a bisector, right? So these are all perpendicular bisectors. And what do we say perpendicular bisectors create? Perpendicular bisectors create circumcenter. All right, next, let's look at this one. It says point D. Point D is the what? Okay, well, let's look. We said those are angle bisectors, right? Okay, well, let's look at our list. What did we say angle bisectors give us? Angle bisectors give us the incenter. Okay, so that one's called the incenter. Okay, what about this one? What do we notice? This tells us it's perpendicular, right? Okay, that's one end. What about the other end? The other end is right over there, right? So it goes from the perpendicular to, on each of these, that's the vertex, right? Okay, so let's look at our notes. Which one is perpendicular to the vertex? Okay, so this one says perpendicular to the vertex. So that's orthocenter and altitudes. Okay, so point D is the orthocenter, and it's created by altitudes. Okay, let's keep it moving. All right, what about this one, point D? What do you think? On this one, we notice these, right? What does that tell us about that point right there? These tell us that this has to be the midpoint, right? And then the other end, let's look at the other end of that. That goes up to the vertex, right? So which one of our notes say from midpoint to the vertex? Okay, so this one says from the midpoint to the vertex is the centroid, and those are called medians, right? So point D is the centroid, and those are created by medians. Okay? So the more we do this, you'll get this. All right, next, let's look at this one. This is switching up. It says point D is the circumcenter, so they give us what it is. We just need to fill in that one blank. Okay, so circumcenter creates what? And maybe you already know. Circumcenter is, right, perpendicular bisectors. All right, what about this one right over here? This one, it says orthocenter. Okay, what creates an orthocenter? Orthocenter is created by altitudes. Right, because we saw it right over here. Orthocenter creates altitudes. All right, what about this one? This says in-center. All right, so which one of our keywords was from in-center? In-center tells us those are created by angle bisectors. All right, okay, and then our last one. What do we notice about this one over here? Okay, what do we notice? We notice that it says centroid, right? So centroid, we said this is one of the most important ones, right? So we won't want to forget this. We want to remember that the centroid is created by medians. All right, so that's it on that next skill. So I know we've done a lot of work, but we haven't done a lot of calculations. So now let's get into our final three with calculations. So these are all centroid, and we know centroid is with the median. So this one, these are the critical ones that we need to keep in mind. Most likely will be on our DCP. All right, so it says in STU, Y is the intersection of three medians. Okay, so let's get back to where we said about the medians. Now this is where this part comes in. It says it's located 2/3 of the distance from the vertex to the opposite side. This is 2/3 of the distance from the vertex to the opposite side. Okay, so what that means is, here's what we need to think. What that means is if the whole thing is 3 units, right? It's a 2-to-1 ratio. This is the longer part. So we can think of this as like 2x. Okay, and if that's 2-to-1, if that's 2x's, then this would be 1x, right? And so we're going to use that when we're calculating these. So all of these are 2x and 1x. So if this was 2x, then this would be 1x, right? If this was 1x, because that's the short part, this would be 2x. Okay, so that's what we're going to think about on this problem. All right, so let's look over here. It says in STU, Y is the intersection of three medians. Okay, medians tells us this is a centroid. Okay, so that's our key word, is that we have a 2-to-1 ratio. That's our hint, okay, because it says median. That's what that tells us. All right, so if that's the case, let's look at what they give us. They say UV is 51. So it's important to trace this out with our marker or something like that. UV, so it goes from U to V. Okay, so that way we don't forget anything. So from U to V, and that whole thing is 51. So here's what we're going to do. First thing we're going to do is draw a picture. All right, so if I have the whole thing, and it goes from V over here, and it goes to U over here, right? And then let's put that Y. Okay, Y is right there. Okay, which one's the longer piece? This one right here is the longer piece, right? So let's think of that as 2x, and let's think of that as 1x. So we'll put 2x over here, and we'll put 1x over here, right? It says UV is 51. So from U all the way to V is 51, right? So the whole thing is 51. Right, so now let's get back to what we did before. Part plus part equals whole. Right, this part plus this part equals the whole thing. Right, so 1x plus the 2x equals 51. right? So that's our second part, is we're going to set up our equation. So now we know 1x and 2x gives us 3x's, right? Equals 51. Now we're just solving, right? The last step is divide both sides by 3, so that means x equals 17. Okay, but now here's the critical thing. We need to substitute. Okay, so the second step is we need to write our equation. Okay, so substitute. Well, what are they looking for? They want uy. So uy is right over here. Uy is 2x. So if uy is equal to 2x, that's going to be equal to 2 times some number, right? What number do we put there? Well, instead of x, we're going to put that 17, right? So we're going to put 17 there. So our answer is 34. Okay, so 34 is our answer. All right, so that's what we're going to do. Is we're going to use that 2-to-1 ratio anytime it says medians or centroid. All right, that's our key words. All right, let's get back into these last two. All right, so SY is 34. Find YW. SY is 34. All right, so let's write that in, 34. Well, what do we notice is these, right? That tells us that this has to be the midpoint. Right? So if that's the midpoint, let's look at the other end. If that's the vertex, midpoint to the vertex, those are called medians, right? So if they're medians, that means it's a centroid, right? So if that means it's a centroid, that means it's a 2-to-1 ratio. Okay, so that's what we're thinking. So the first thing we want to do is we want to draw that picture, right? So they're talking about SY, right? So let's look at that SY. Let's trace that out. SY, right? And let's keep going. So SYW. So SW, and then Y is right over here, right? That's the short part. Okay, so we're going to say this is 2x, right? And that's 1x, right? And then SY, though, just the short part is 34, not the whole thing, right? The short part is 34. Okay, so they want YW. Okay, so they want this short part. Okay, so here's how we think about it. If this is 2x and this is 1x, that means this has to be half of this, right? So if this is 34 and that's 2x, half of that would give me 1x. So if 2x is equal to 34, that means that if I divide that by 2, that means x equals 17. So that's what they're asking for. They want to know how much this short part is, YW, right? So that's our answer, x equals 17. All right, so now let's do our final example. We got this. All right, last example, it says in triangle HIJ, N is the intersection of 3 medians. All right, cool. So we know with medians, we know we're dealing with a centroid, right? Centroid tells us the lengths are 2-to-1 ratio. Okay, so let's trace that out first. It says Ki is 30, right? So Ki. Oh, snap. Let's look at that. This is the side, right? Well, what do we know? If that's the median, this has to be the middle, right? So if that's the middle, if KAI is 30, that means this side is 30. They want HK, right? They want to try to find out from here to here. Well, what do we know? If that's 30, this much has to be 30 as well. All right, so that's our answer is 30. Okay, so HK is 30. All right, so that's it. On these last ones, we just got to remember the medians. We're going to use those 2-to-1 ratios. So let's take our highlighter with a different color so we can box all those answers, right? So that was our final answer on that was 30. This one was x equals 17, right? This one was 34. Okay. Then we had medians, altitudes, perpendicular bisectors, angle bisectors. Centroid median, orthocenter altitude, right? Circumcenter goes with perpendicular bisector. Angle bisectors go with incenters, right? And altitudes, medians, angle bisectors, perpendicular bisectors. All right, so I know you have this. If you have any questions, just let me know.